In order to understand the valuation model, the standard deviation of the valuation of a particular stock or a portfolio of stocks, yeah, what we want to do is to go over some real fundamentals and basics, and it's also important to understand all of these in order to get the concept of how in the world do we price the most probable price points of the next upcoming day at the end of the current day. So what we want to do is just go through uh, growth rates and also take a look at standard deviation model, another way of looking at it graphically. First thing to do is just take a look at a simple arithmetic chart. Right along this x-axis, we're looking at, let's treat this as years, 1 through 5, and then price of a stock, 10, 20 through 50. If at the end of the first year, right at the end of year 1, we were to purchase a stock at $10, and then we held that for the next year, at the end of the first year, going to the beginning of year number 2, we went from $10 to $20. So what we want to see is what's the growth rate from the end of that first year, from the beginning of that first year to the end of it, for that 1 year period. And it's obviously, you go from $10 to $20, it's 100%. Now, what's its rate of growth from the second year to the third year? Is at $20 at that point, and by the beginning of the third year, we've gone from 20 to 30. But then that rate of growth, even though we've got a straight line here, is only 50%, because you've got an increase of $10 from 20 to 30. That $10 increase divided by the beginning of that point in time $20 value is a 50% increase, and it just logically follows. If we take a look at the value here, it's at $30. We want to see that its growth in the next upcoming year, and it grows another $10. So now it's 10 over the 30, so it's only 33%, and so on. If you go from 40 to 50, you've got a $10 increase from the starting point at the beginning of year 4, $40. So you've got a 25% rate of growth. So it's a normal arithmetic scaling where you have the same dollar incremental increase graphically as you're looking at this y-axis in relationship to the x. Now let's change the scaling from 10, 20, 30, 40, 50 on that y-axis, and let's just change it. What we're going to do is it's the same distance, but the value is going to be doubling. It's a logarithmic scaling. So now, again, we start at year 1, it's $10, gets to year 2 to $20, so you've made 10 on your 10. Once again, it's 100%. Now, it moves along this same graphic right here, straight line, as we had before. Now it moves from year 2 to year 3, but it moves, and when we have a log scaling, it has increased in that 1 year interval. It's increased from $20 to $40. So we have a $20 profit on a $20 starting point at this juncture, from this juncture to that juncture. So once again, on a log scale chart, that straight line, you can see it went from here to here, it's 100%. Here to here, it's 100%. Same thing. You go to this level, you're going from 40, year 3 to year 4 to 80. Well, now you've made $40 on what? A beginning point at right at this juncture of $40. So once again, it's 100%. Same thing. You go from year 4 to year 5, it goes from $80 to $160. Consequently, you have $80 made on that during that year, with a starting point of year 4 of $80. So once again, 100%. So you can see on a log scale chart, a straight line from any starting point. In this case, we're just going from the very bottom left, is a growth rate, and that is true on log scale charts. So consequently, if you had a stock on this chart, and it was, it kind of had this undulation that was moving in this path here, you could literally take, and if this is a plastic overlay, you could grab this chart and take this pivot point right here and move it. You could actually take this left-hand corner and you can move it anywhere along that stock chart. You can take it and plant it on a price and then see what, if the price level tracked on any one of these lines from the corner, you would see that it was a growth rate. In fact, I just started them all right here from this point. So in other words, if I grab this chart and I put it in the stock, followed this track right along here, it's following this track. Anytime it hit that line, it's 41%. If it fell down to this level, it's between 19%. So that's essentially the concept. That's all I wanted to get across. Is a log or semi-log chart. A straight line is a visual of a calculable growth rate. So now let's go ahead and in fact, I'm going to be coming back to this point later, this particular image. So what we're going to do is flip over to a chart. DuPont. This is a monthly chart. You're looking at DuPont, symbol DD. You're looking at, this is a monthly. Every bar is a month, going all the way back to 1970. This is the time I took this. This was back in 08, somewhere in there. And you'll see that it's a normal arithmetic scaling, 10, 20, 30, 40, 50, and so on. Now, if you take this and you see this parabolic growth rate and put it to a logarithmic scale, all of a sudden, that growth rate, while it will still undulate because we're talking about a publicly traded stock, it will undulate, but you'll see that it's fairly doggone linear. When it finally breaks, it breaks, and it's fairly doggone linear. Let's take a and you can see how it just follows that particular path. Same thing on the drop here. Same thing as it starts to flatten out. Now, take a look at General Electric. Same thing from 1970 all the way through, and here we have the 2000 crash. But now you take a look at it, and it's pretty doggone linear. Linear here, then it had an accelerated growth rate. That's a very calculable growth rate. We'll just put it right along those bottoms or straight through the middle. Very calculable. Chevron, take a look at that. It looks like it's taken off to the moon, and yet very, very linear all the way through all those years, over 30 years. Here we're looking at Hewlett-Packard. Same thing, same parabolic, very dramatic drop, very dramatic rise, but all of a sudden you put it on a log scale chart and you can see that the price action is pretty darn stable. Again, if this were a private company, never publicly traded, these undulations would have really smoothed out, almost become very, very linear, even more so. Here's Microsoft. Take a look at that when it, here's around 1985 and just took off like it went to the moon, and yet very, very linear. That is a 60, I think I calculated once, right up the middle. It's about 62% annualized compound rate of return, and then it finally broke. Here's the Dow, taking it all the way back to the 1920s, and you can see once the monetary inflation system really kicked into gear, prices actually really took off, but when you take a look at it on a log scale, not so much. Very, very, here's the crash of 29. I'll go back on that. I'm going to go backwards on that. And we'll go page down. Yep. You can see there's the crash. There's the crash. But from there, it's just, it was very linear. Linear, linear, linear. This was unsustainable. When we got to 95 all the way to the top of 2000, that was a 22% annual compound rate of return. This is a reflection, the Dow is a reflection of the entire economy. It just could not sustain itself, and it fell right back to about a 7%, a little bit less than 7% rate of growth, starting from the very beginning, post-war in the 1940s to that point. It got from 22 back down to around 7 or 8. I'm going to cut this right now. I don't want it to be too long for the YouTube, and I'll continue it from here.